one. The basic three. Open. Let me see. Yes. All right. Let me just figure out where this one is. Okay, all right. So let's start with symbolic calculations. Right. Let me make this bigger. All right. So in this case, we are going to discuss just basic polynomial operations, algebraic equations, a little bit of symbolic calculus and simplification. So we're going to start with polynomials. And whenever we have polynomials, we are lucky because those are the easiest ones to solve most of the time. All right. So we can use solve, simplify, integrate. We can clearly define rational functions as well. And the typical operations for polynomials are factor and expand. Those are the typical ones, right? So imagine that we got this expression and we want to factorize the expression, right? So if you have to do this manually, I do pushing report. In less than a second, Mathematica already figured it out. So again, what I was saying is we shouldn't be wasting our time in this kind of stupid, operations, right? We focus on the important things. So Mathematica can do this for you, So once we got this, if you want to know whether this is correct or not, you can use the opposite operation, which is expand. All right. Again, we can see the two golden rules, right? The usual. F, capital F, right? Square brackets. We know X sama Y biru. Kenapa? Warna biru. There is no definition, right? It's just symbols that they don't have any definitions attached to them. So we are saying, kita aman. Kalau sekarang di sini X sama Y biru, aman. Mereka cuma simbol saja. Kalau sudah ada definisi, itu repot. Pasti kayak jalan. Okay? So factor and expand. And again, look, another interesting thing is from here we can even create, 3D plot. We can do full simplify. We can factor. We can calculate the x derivative. You guys know what I mean? We can try to take advantage of Mathematica suggestion tool. Look, once you become very familiar with Mathematica, this may be annoying, alright? If this annoys you, you can always shut it down. So you can click here on minimize suggestion bar. You can click it and then it's gone. It doesn't bother you anymore, right? But if you want it back, gak apa-apa, bisa juga. Just click on this one. So, suggestion bar. Alright? So, another typical operations of rational functions are we can put two rational functions together or we can separate them. Example, for integration, sometimes we need to separate, right? So, this is again typical example. We got this expression and we want to, put it apart. Or put it together in this case because it's already apart, right? So, there you go. Now, how long would it take you to do this manually? A long time. And chances are we will still get it wrong, right? So, we just directly did it. So, all these are very common expressions, alright? So, yesterday, if you guys remember, we used n solve. What else did we use yesterday? Find minimum, right? We talk about n. We talk about ND solve, right? For numerically solving differential equations. Today, we're learning new ones, right? So for symbols, especially polynomials, we're talking about expand, factor, together, apart. Look, do you guys know how many functions we have in Mathematica version 9? Siapa yang tahu? Kira-kira. Berapa commands? 100, 1000? More than 4,500 commands. Nggak ada orang di seluruh dunia yang master semua. Don't worry, we don't need to. Jangan khawatir. Yes.
Apakah ada mind map sehingga kita gampang berikan ini sini dan sini?
Oh ya, mind map ya. Mind map.
Mind map dari perintah-perintahnya ini.
As far as I know, there is no mind map. But the good thing about the help file, when you look at the when you look at the function here, so you got something called function navigator, and from here you can choose the area that you're trying to work on.
Oh, okay.
All right, but as far as a mind map, I have not found one.
I'm waiting from Ruben.
So, you know, if you want mathematics and algorithms, you can look from here, right? So you were asking me yesterday about graphs and networks, so it's here. All right, so yes.
For numerical computation, I'm just worried about the algorithm.
Yeah.
For example, for integrating something,
yes,
there are so many algorithms.
Correct.
So how can we estimate that the errors in this algorithm used by this expression can be, because there is symplectic integration, for example, there is
that's a good point. Usually, if you need to get more familiar with it, there is a very good tutorial about numerical integration that goes quite deep in terms of the algorithms they use.
okay. So there are some function.
It will explain to you, you can choose methods, etc., etc. But if you have access to other software, or let's say you already have your algorithms developed in C or Fortran, you know, you can double check.
Yeah.
If you still feel that the numbers seem odd, you can always email them and ask them for a more detailed explanation. Email Wolfram, or you can email me directly. That's okay. I'll forward your concern to Wolfram. But that's a good point. But they do have some you know, PDF files and tutorials that go much deeper into, you know, the algorithms and the techniques that they use and the potential problems that you may find. I agree with you that numerical integration we could spend, you know, weeks discussing all the problems, especially if we're talking about, you know, complex domains and poles, etc., right? But what I'm trying to say is that, you know, you can find the information here, and if you have any problems or you're not sure, you are getting different results from different pieces of software, you can always contact me or contact Wolfram directly. But they do publish advanced numerical here. You see, tutorial collection. This is advanced numerical integration in Mathematica, and this will take you to a place where you can download for free the PDF, and it will explain to you all the algorithms they are using and all the potential problems. This tutorial collection is for free. You can download the PDFs, and it covers everything in Mathematica. So you have more than 5,000 pages. You guys can take a look at the tutorial collection here. Yeah, it's Wolfram. Wolfram.com Learning Center / tutorial collection / index. That is available from inside the help files. So you can see that. Sorry, let me make this bigger. You can see that here you got for the core language, for advanced string patterns, mathematics algorithms, advanced algebra, advanced numerical differential equations, advanced numerical integration, 174 pages. Just dealing with advanced numerical integration. And constraint optimization, random number generation for cryptography, alright? For example, there you go, 39 pages, just focus on random number generation. So that's why I said, we don't really have time in 2 days to cover everything, but I'm hopefully giving you some, basic foundations and some hints about how you can, start your life journey mastering Mathematica. It's a life journey, actually. You never finish. But that's great. I mean, I love it because, Mathematica then will have even more functions.
Okay, so it's free.
Oh, yeah, it's free. It's free. You can either download a PDF or you can read directly on the internet web page. Alright? Ada pertanyaan yang lain?
Luar biasa. Luar biasa.
Alright, so in case you guys are curious, let's find out how many commands we got in Mathematica right out of the box. Yes? Let's issue this command. Len names system so I'm asking Mathematica to give me the length of the list containing all the names that exist in the system context in Mathematica. Yeah, so this is the context where all the Mathematica built-in commands are located, and asterisk means all of them, right? 4,570 commands. If you want to know the names of all of them, you can just remove the len, okay? And that's it, enter. There you go. Remember, 4,570. As I said, there is no one anywhere in the world that has mastered everything in Mathematica. No, even Stephen Wolfram, yes. That's correct. But I think that's what makes Mathematica great, because you see, you got all the community trying to help, you got a specialist in this area who can help another person who's not familiar with that area, etc. etc. Alright? Anyway, so now we talk about roots and algebraic expressions. And, as usual, so any expression that can occur as a root of a polynomial is called an algebraic expression, right? Actually, if we could also, remember what we did yesterday? Sometimes we are having difficulties with a concept, or we're not sure about the definition, we can ask Wolfram alpha, right? Do you guys remember how to do that? We can put equal, right? And we put what? Algebraic expression, right? Oh, salah. Salah pencet. Let's see. If Mathematica understand? Yeah, but you see, understand. It doesn't matter. Even though salah pencet, as if it's like empty, huh? But it's pretty cool. I mean, if you want to clarify what are you talking about, just really quick natural language, there you go. Algebraic expression represented by the variables and algebraic numbers using addition, multiplication, and rational powers. If you need more information, as usual we discussed, right, you can click on plans. Yes? So it's telling you, you can go to math wall, algebraic equations. So, as I said, it's really pretty cool. Anyway, then we got a radical, so it's an expression with an exponent that is a rational number. For example, radicals are frequently used to represent roots of polynomials, alright, so 2 raised to the power of half, yeah, so it's going to be a radical, an algebraic number. Anyway, so we can use the solve function, we already learned how to do that yesterday, if you guys remember. So it's worth noting that non-algebraic expressions can be represented using radicals. Yeah, we already know that, right? Who was the guy who proved this historically? Anybody knows? Anybody from MIPA here? MIPA? No MIPA? Yeah, so it is worth noting that not all algebraic expressions, roots of polynomials, can be represented using radicals. For example, fifth degree, right? Cannot be represented using radicals. There was a famous French guy who died very young. No. No. Galois, yeah, okay, very good, yeah. Anyway, don't worry. So what happens is, because we cannot represent that, then Mathematica is going to give us something really weird. But we don't need to worry. It means it just cannot be expressed using radicals. But numerically we got the solution. If you guys remember, when we just find instance, we sometimes got these results, right? We can just turn them to numbers just by applying. Let's see here. That would be interesting, right? Am I getting any suggestion for... Oh, interesting. Look, in this case, we are not getting any suggestion for the numeric value, right? So you know what we can do? We can click here and we can complain to Wolfram. So we can send them feedback and letting them know, hey, how come you guys, you are not, offering to come up with a numeric solution? So they are constantly updating the suggestions bar based on the inputs from users. So the more you use it, the better it gets. Kind of using machine learning algorithms. Alright? Anyway, so now we can find the numeric solutions that we discussed earlier, right? And now we can also play with factor. In this case, factor does not give us anything, right? And we got the reason introduced here. So how can we fix that? No problem. We already know the solutions involve the square root of 2. So in this case, we add an option to factor saying that the extension is going to be a square root of 2. So we need to clearly specify the algebraic expression. So what the point here is that, look, sometimes you try to use a command in Mathematica and the command does not work as expected. What happens is you may need to look at the options and try to change the option by default. If you guys remember, I showed you yesterday a command to find the options, right? Do you guys remember the command? So here, the command was options, right? Options factor. Remember, here we are trying to change the extension, right? What is the problem? Let's take a look at the default value for extension. Extension none. You see? Because of that, we got in trouble. So there are many commands in Mathematica that require you to maybe change the default, especially with numerical integration. So that's the idea. In this case, once we change the norm to the square root of 2, because we know those are the solutions, then the problem goes away. If you guys remember, yesterday we discussed the differences between 2 and 2.0, right? 2 is an integer, is exact. 2.0 is an approximation, right? And that impacts precision and accuracy. Remember, yesterday we discussed that? So this is the same. So in this case, we try to factor this one. No problem, but we try to factor this one. Doesn't work, right? So why this second option doesn't work? Again, because of the 2.0, right? So this is exact, this is exact, this is not exact, right? So Mathematica cannot handle it. So be careful, be consistent with the way you are entering the expression, alright? So make sure that everything is exact or everything inexact. If you enter everything inexact, for example, sometimes when you try to do solve will not work. Solve needs exact parameters. Right? Anyway, here another problem that you guys may experience. Right? So again, you can go through it and try to read. This is interesting. How do we solve this one? We got, again, the pair of equations, right? And we got the list of solutions. And by now you guys know how to get information from here, right? And what we got is the solutions that we discussed as a list of rules. And then we can use those rules to make substitutions to other expressions. And we can check that the solutions are correct. Remember, yesterday we did an exercise for that, right? can you prove that the solutions are actually correct? And if you guys remember, we use the replacement here. So now we can replace in this expression values x and value y, right? And make sure that we got c and 0. Take a look. True. And then when we simplify the expression, we got. So this is good practice as well. Just because we get the solution, is it true or not? Can we check? You put it back to the linear equation. There you go. You guys should be familiar already with this command, right? What is the meaning of this command? And assign the value to the symbol x. And the same for y. So we are already familiar with those things. Very good. Now you see x and y jadi intan. Remember now they are not symbols anymore, right? They already have values. So if you are trying to use factor, expand using x and y, you have to be careful because it may not work as expected. Now, if we try to do this, we got an error message, right? Yesterday we got a lot of error messages like this. Kenapa? Because x and y are not empty, right? They already have values, so we cannot solve. X and y have to be symbols. That's why Mathematica is complaining, right? So I bar x, it cannot be solved because it's not x anymore. It's minus 1 minus the square root of 1 plus c. One thing that I would like to encourage you to do is, look, every time you got an error message from Mathematica, look at it. Yes? Because it's giving you a hint about what went wrong. So it's much easier to troubleshoot. Now, this will work when we do clear xy, right? You see? Now, if we try to solve it, again, this will work perfectly. Alright? By the way, if you want to start clean, let's say you have defined a lot of variables and you want to remove all of them, yes, or clear all of them, we have two options, okay? One possibility would be to go, like we discussed yesterday, evaluation with kernel, but if you do that, all your definitions for functions, etc., will be gone as well, yes? The other alternative, the other alternative would be to use clear, but to clear all symbols. Yes? How do we do that? How do we clear all symbols? Siapa yang tahu? So it would be, okay, so the first thing probably we could try is something like this, right? Clear. Oh, look at that. Alright, this is interesting. I've never seen this function before. Clear all values and the whole associated with symbols. So, is this the one that I need? Let's check it out. Now, in this case, it looks like this might not be the case. But what about clear? So, if I check out the scope, I look for an example that, look at that, I found it. The help is wonderful. Just, take your time to go through the examples. Honestly, you will find most of the solutions to your questions there. It just takes time because it's such a vast system, right? But you got thousands of examples. Honestly, and in this case, look, we already found it. So all the symbols that we define go to the global context. So there you go. We clear all those symbols by using this command. That's it. And because the help file is completely interactive, then, we can execute directly from there. Yeah, it's not that we have to copy and paste. No. All the help files are Mathematica notebooks, actually. Yes? So you can execute there, or you can just copy the cell to your notebook. So that sometimes can be quite useful. All right. So let's talk about derivatives now. Yeah? Again, what is the derivative of this? If we are learning derivatives, we could use step by step by our friend Wolfram alpha, right? Do you guys remember? How do we get step by step? We got equal, right? Equal derivative of cosine x times x for x. Yes? And I click on the plus sign. So if I'm trying to discuss, how to find derivatives with my students, or I'm finding a quite difficult derivative, I could just click on a step-by-step solution. And again, as long as the internet connection is good, Mathematica will guide me. There you go. So I use the product group. So it's giving me step by step, and then it's giving me a lot of information, the plot of the function, etc., etc., etc. Even the numerical roots. So I can even learn Mathematica here. With working precision, we discussed all these things yesterday, if you guys remember. The properties, I got the domain information, I got information on the definite integral, etc., etc. So it can be quite helpful, especially for learning process. Alternatively, we could just find the derivative for, again, a function that has not been defined. We could do that as well. No problem. Mathematica doesn't care. It handles both symbolics and numerics perfectly. So 2 times f prime x plus x second derivative, right? Why is that? Because here we're calculating the second derivative. Right? If you are a bit confused, you can take a look at this full form. Remember the trick yesterday? We talked about 2 plus 3, right? But actually, Mathematica understands it as plus 2, 3. So this is the same. When you use full form, what do we get? The derivative, first derivative, right? And the second derivative. So this one,
Ruben,
yes.
this is me.
Yeah.
What's the meaning of cursor that change to arrow? Like this. What's the meaning?
This one. This is Mathematica expression.
No. The cursor is changed to arrow. What's the meaning?
Yeah. So it's about the statistics. The full form. No, it's just the full form.
Oh.
So it's information about the kind of the output. Yeah, that's it.
Yeah.
Okay. Any other questions? No? Alright, so that's for derivatives. We can calculate the third derivative of cosine. We can use the prime notation. Can you guys do the same using the derivative notation? Calculate the third derivative of cosine using the derivative command. Can you guys do that now? In 1 minute?
Yes.
2 minutes then. Yes. Okay.
And then
Sometimes when you don't use Wolfram alpha, that's one of the issues with Mathematica. With natural language, the system it becomes sometimes unstable. That's why I strongly recommend to save the work quite often.
yeah.
Already, using the derivative command. Derivative, right? And then what? Any ideas? We could use D, right? Cosine x for x, and then what? Would this work? Let's take a look. How would we use it in Mathematica, even if we haven't used the function before? Again, the example will save us, right? The fourth derivative. So, what is what we should do? Instead of using x and 3, I need to put them between curly brackets, right? So, even if we don't know how to really use the function, it's okay, just go to the help file and we will find the example to suit our needs. Alright? There you go. So instead of using this notation, we can use this notation, right? So this is first derivative in terms of x, second derivative in terms of x, but the third derivative in terms of y. Okay. There you go. Then we can do symbolic integration, of course. And then we can check that the result is correct by, again, applying the fundamental theorem of calculus, right? Yeah. Differentiate the result in terms of x, and we got back the function. We can even try to do integration between symbolic values, right? So Mathematica is telling us it will be cosine of x1 minus cosine of x2. We can do several multiple integrals, alright? But again, the structure is always the same, as you guys can see. So, of course, if you're not sure about the results, what can you do? You can calculate the numerical integral directly. So instead of calculating the defined integral, let's calculate the numeric integral directly. So in this case, we get this number, and we check that the number that we get is the same as the number for numerical integration. Because the numerical integration command will use different algorithms from the symbolic integration. But of course it will go faster. Alright, so my advice, if you are dealing with very complicated integrals, do not try to solve symbolically. Mathematica may be able to do that, but it may take a long time. Just directly use numeric integration. Sometimes we need to specify conditions. Let's take a look at this one. What is Mathematica telling us? Mathematica is telling us this integral is b as long as the real part of 1 over b is greater than 0. Okay? So, if you know that, what can you do now? Well, we can put like this. We can enter an option in integrate saying that my assumption is that this b is greater than 0. So, directly, what would be the solution then? B, right? Because I'm taking into consideration now the assumption right away. I'm saying the assumption is b greater than 0, so Mathematica directly tells me the solution that I'm looking for. Then yesterday we talked about n dissolve. Today we talk about dissolve because it's symbolic. So the same, n integrate, integrate. Again, so the typical example would be this symbolic differential equation. So the derivative is equal to the function itself, right? And we differentiate. These are the arguments, function, and the variable. There you go. C1 is the constant. Alright, so what would be the value of this function is C1 equals to 7. Can you guys give me the value of fx if C1 equals to 7? Again, you guys should be able to do this calculation. Right? How do you do it? Exactly, replace, right? How do we do that?
Slash dot C1 equal 0.
So replace C1 with 7. Very good. So all these things we should feel quite comfortable, right? Of course, the reason we have C1 is because we haven't defined any initial conditions, right? If we have initial conditions, the C1 will be automatically been defined.
In the option bar, we will see, for instance, plot can be
in the suggestions, or
for instance, we want to see the plot of this.
okay, yes.
We have to do a manual comment plot something.
Yes, correct. If in the suggestion it doesn't show up, yeah, correct. We'll have to do it manually. Where is my? Oh, okay. So my Mathematica. Okay, so that's my suggestion. You see, you're right. But sometimes you may have here more solutions available. So under the more, sometimes you may have more options, and that's actually the option that may allow you to do that. But yes, you're right. If there is no suggestion here, you may have to do it manually. Yeah, can you guys please plot this function between 0 and 7? This new function? That should be fine. Okay. Ya gimana? Sukses? No, yeah, belum. Kenapa? Matematika goblok ya? Oke. Ini? I see. Let me, mungkin I'll explain in class, right?
Okay.
In front. So, look, it's very good that we are making these mistakes now, so we understand what is wrong, so we don't make the mistakes again. So that's the idea. I usually I encourage people to make as many mistakes as possible, so you learn from those mistakes. So if someone asks me to do that, okay, so the first thing I will do is, yeah, okay, so I need to plot, right, f of x, correct? Between x equals to 0 to 7, right? Yes or no? Yeah, okay. And then I press shift enter, do Mathematica lo close it. Kenapa kosong? Itu fx sudah ada sini, right? And I get back, right? But I don't need to get back. I need to try to understand, okay? Look, this f is blue. So first of all, Mathematica does not understand. But I already know the rule to replace that f of x, right? Yes or no? What is the rule? The rule is this one. So if I want to plot the function, I just need to tell Mathematica, look, I need you to replace f of x with this, and then plot it between 0 and 7. You see? So the idea is good initially, but we are short of the instruction about replacing f of x with the actual function. So how do we fix that? Okay, the way we should fix that would be like this. So I put solve like this, right? And then I put solve again like this. So now I got, right? I got this rule stored in this variable. In variable solve, right? So now if I tell Mathematica, okay, please plot now f of x, but replace f of x with e to the power of x times 7 using this variable, right? Now it should work fine. Alright? So that's the idea. We try to understand why, how come, sometimes it can be tricky, alright? Why Mathematica is not giving us a result. I don't have all the answers myself. Sometimes I'm like, oh my goodness, I have no clue why it's not working. But, you know, it's good that we can make mistakes and we learn from those mistakes. Alright, so here is another example for this all. The same structure, but in this case we already got some initial conditions, right? So, because we don't have initial conditions, we should not have C1 or C2. In this case we already got directly the function, right? So can you please plot this one between minus pi and 3 pi? Can you guys please plot the solution between minus pi and 3 pi? And then, sorry, then we take a break, if you guys want. This, right? Remember, Mathematica gave me this as a solution. I want to use this to plot the function. I don't want to do it manually. You guys understand what I'm trying to say? I know I could directly type myself cosine x, but that's not the point, right? The point is to use the rules, to use the output from Mathematica. So, one more time, the idea would be to use plot, right? Plot f of x, but replace f of x with the rule that I just got. That's what I'm trying to emphasize here, right? That we use, we get used to this way of Mathematica returning the solutions to us. Believe me, you will be doing a lot of calculations, right? And Mathematica most of the time will give you the solutions as a rule. Yes? If we get used to handling this output, our life will become much easier. So this should be like second nature to us. Now we don't need to think. We already know, understand. So you already know. Okay, so Imana, take a break now? Yes.
What is the law?
Raise it to the second power. Yes? Alright? Can you guys create now a pure function to calculate the cubic root? The cubic root. A pure function to calculate the cubic root. Gerti masuk saya. Yes. The symbols, defining everything is just an error. So it's a very, very powerful concept when you start playing with Mathematica. And many of the examples, they use this. It's not easy to master. It takes a while, but it's quite useful. Gimana? Sudah, success. Your function untuk calculate the cubic root. Gimana? Sudah, success. Belum. Ini susah. Oke, nggak apa-apa. Gimana? Sukses. Belum. Oke. Harus seperti ini.
Banyak jalan belum. Yang paling cepat.
Gimana sih? Oh, belum. Oh, okay. Yeah, bagus. Tapi that is not the cubic root. I mean, a function. So, don't worry if you don't understand 100%. I'm just introducing the concept to you. It may take a while before you master it. But the idea is, if we want to create a pure function, then we use the slot notation, right? So this will be the argument, and I want to raise the argument to 1/3, right? Alright? And then you see that the color of the argument is not green, right? So meaning Mathematica still does not understand. I need to tell Mathematica that this is the value of a pure function. How do I do that? By putting the ampersand. You see, automatically becomes green. So now Mathematica understands. This is a pure function, right? So this is a function, this is the value of the function, I need to give it an argument. So the argument, for example, could be a. Yes, and I use, again, square brackets, as usual. Okay? So, can you guys create a pure function now to add 3 numbers? Pure function that will add 3 numbers. How do we do that? Again, the first argument, right? Plus the second argument, plus the third argument, right? Yes, and I need this to be pure function, correct? So I need to give it the ampersand. And then I'm going to give it 1, 2, 3, 3 arguments. So it will take the first argument, right? Plus the second, plus the third.
What is the purpose of this kind of syntax?
The purpose is when you are trying to use, for example, functional programming. You're trying to map a function to a list of elements. You use this a lot. Alright? Because Mathematica was designed mainly for functional programming. And the easiest way to do functional programming is with functions, but it would be very annoying to define all the time the functions. So you don't need to define them, you just create the pure functions and it will automatically be done for you. What's that? Oh, because we need to create new settings. You see, the setting is there. That's why we create a new setting. Now you understand. Okay, imagine that I got. Okay, you asked me why would we use this, right? So let me give you an example, all right? Let's put list. All right, so this is my list, and imagine that I need to calculate the distance between these coordinates, alright? So, what is the distance? So, according to the definition, would be this square, the square root of this square plus the Euclidean distance, alright? This square plus this square root, right? Of the sum of the squares of this. Yes? So, I would need to create a function, correct? But it would be kind of annoying, right? So, in Mathematica, again, to solve a problem like that, I can take 3 approaches. I can use procedural, very long. I could use patterns-based or rules-based, alright? Or I could use functional, alright? If I want to use functional, it means that I would like to map the distance function to each of these elements. Alright? Yes? So, how would I do that? Okay, if I issue this command, what am I gonna get? Okay, 2 or 2,5? Alright, why? Because the first element is the list, right? But if I want the first element of the first list, then I would issue what? List? 1? 1, right? Yes. Why does this work? Because if I go to tree form, list, okay, let's take a look. You see, this is my 0 level, right? This is my first level, and I want the first element, right? So this will be 0, 1, 1. So that's why I need to put 1, 1. And so if I put only 1, I get the list, right? For example, if I put 3, 2, what do I get? Very good. 90, right? 1, 2, 3, 1, 2, right? You guys understand that? So far so good. Alright. So if I want to create a yes. Belum jelas. Oh, you want me to? Yeah.
Nah. Right.
We discussed this function yesterday, right? I said it's very, very useful. The same with full form. Remember, those two functions are very, very useful in Mathematica if you try to understand what's going on. Tree form and full form. You guys should try to remember that because they will save you a lot of headache when things don't work. You will understand why now. Alright? So, imagine that I want to create now a pure function, alright? That will calculate the distance. Yeah? How would I do it? So it would be kind of a square root, yes? I use the sexy notation, yeah? Control 2. Two-dimensional notation, the sexy one. Of what? Remember the definition, right? The distance is the square root of the square of the elements, right? Yes? So, what do I need to do now? Do you guys understand this notation? Siapa yang bisa jelaskan? Saya masih bingung. Artinya apa ini? Element 1, a square, right? Plus element 2, square. Sorry, ya, salah baca. Thank you. Terus? Control 6, the sexy version, control 6. Oh. Terus? Ampersand. Oke? Nah. Terus? Gimana sekarang? Can you guys calculate this using as the arguments, right? 2 and 3 as the point. The point is 2, 3. Can you give me the distance for that point? 4 plus 9. No, 2, 3 are exactly. Yeah, it's okay. Never mind. 2, 3. Yeah. No, just use as a point, just use 2, 3. But before that, we need to define a function. Harus jadi 7. Kalau dia jadi 7, belum function. So calculate the distance of the point 2, 3 to the region. So the argument, right? Yes or no? And I do this, and I do this. Right? Right or wrong? Aduh, Mathematica goblok sekali. This is a very, very common mistake, and it's very important that we understand why it's not working, alright? So who can tell me why it's not working? And how do I fix that?
We didn't give the index.
I didn't give the index. Oh, alright, so there is a mismatch between this and this, right?
Yeah.
So I could fix it, how? By putting here slot 1 and here slot 2. But, if I do that, then I will not be able to apply this function to my list. Because remember, I got a list of lists. So how do I fix that? Yes? Ah, very good. So this is the problem. Here I have given Mathematica 2 elements, right? I need to give Mathematica just one element. And then Mathematica will pick the first part of that element and the second part of that element. That's why if I change these 2 and 3 with the list, now things make sense. You guys understand? Oh, still very confused. Huh? Don't worry, this is very advanced. But you know, I'm trying to give you a picture of the things that you can do with Mathematica. This is complicated, but if you can learn to think the Mathematica way, wow, you realize that solving problems is going to be much faster than the traditional way. And so remember, I'm taking the first part, right, of this, which is 2, right, the square, and the second part of this, which is 3 square, right, and I can put it in the square root. Yes. Because you have here something that
What's up?
This is where is that difference of this function? What is the function and what is the element? There is no separation between function and element. Square root over 7.
This name is.
Compare that one with this one.
Oh.
What do you see? This is my function, right? These are my arguments. You understand? But in your case, the square root covers everything, right? So there is no separation between function and argument. How do you fix that? Yes? So then this notation is the one that will do the mapping for you. Gimana? Sudah? Jelas? No, you don't put anything you want here. This is just an argument. Whatever you want. Oh, if you add one. Yeah, correct. Yes, correct. You can do that, Gimana, sudah? Okay, so we got the structure. We got the structure of the pure function, right? Yes, but remember now, I want to apply this pure function to those 3 coordinates, right? So how am I going to do that? I'm going to map. Yes, so this is how it's going to happen, all right? I'm going to do the following. All right, so okay, so I got the list, right? Okay, so let's do this. I'm going to use the command map, all right? And this command will allow me to apply a function to the elements of a list. The function, I already defined it, right? The function is this one. This is my function, correct? So this is my function, and now I need the elements of the list, right? But I already know the list is the list, correct? Because I already put that there. So I'm going to put list. Huh? Alright?
Why should we put comma?
Oh yeah, because map will take 2 arguments, right? Map will take the function and the list to which you want to apply the function. Belum jelas? Okay. Sorry, no problem. Yeah.
Oh my, okay. Okay, I missed the map.
So what's going to happen now? If I shift enter, then Mathematica directly apply the function to each of those elements, right? There you go. Can you do this with procedural programming in one line?
No.
So what is exactly the meaning of ampersand in this case?
That is the definition of function. The ampersand means function. Here, if you're in doubt, you can always remember the trick, right? Just double click and press F1. Function, right? Here. In this context, the ampersand is function. You're telling Mathematica that that is a pure function structure. Alright? Look, don't worry, don't feel bad. This is very difficult. It took me several years for me to really master this. So don't feel bad, this is our second time. I'm just giving you some, brief snapshots of the power of Mathematica. Yes? The idea is for you to struggle trying to understand. No pain, no gain. Yeah? And of course, if you get in trouble, just contact me, no problem. I'll be more than happy to help you. But once you really understand how this works, wow. Honestly, you can come up with algorithms, solve problems very, very easily. Actually, when I give solutions to people, they don't believe me. What? 2 lines of code? No way. They don't believe me, honestly. I have half page of procedural programming and it's not working. No, you just need 2 lines in Mathematica. They don't believe you. And most of the time, there are situations where you're trying to do the function and the function already exists in Mathematica. Actually, the function already exists. I was teasing you. The function is called distance. But I just wanted to, show you the way that functional programming works. So, let me show you also, because I know we're not going to have time to cover everything, but let me show you how we would solve this problem also using rules-based or patterns-based, alright? Yes. So, this is the interesting thing, alright? I'm going to tell Mathematica to identify what pattern? A pattern of a list with 2 elements, alright? You guys following me? So I'm going to tell Mathematica, look, every time you find a pattern that consists of a list with 2 elements inside a list, I want you to square element 1, I want you to square element 2, and I want you to calculate the square root of the sum of those 2. Understood? In plain English, right? Yeah. The difficult part is to translate that into mathematical language, right? Let's try to do it. Yeah? So, in that case, what I'm going to do is like this, okay? I got my list. So, sorry, let me just put it where? Here. Alright? Let me solve the same problem again, but using, I got my list, and I'm going to tell Mathematica, look, I need you to replace this pattern, right? Do you guys recognize this pattern? This is a pattern in a list with 2 elements, right? I'm going to name the element A and B. You can name it ITB and Bandung. I don't care, whatever you want to name it. Alright? The point is that we need to have 2 arguments, right? And I need Mathematica to change that to what? A squared, very good. A squared plus B squared. Excellent. Look at that. Wow, it works. Oh my goodness. Silence. You're still busy trying to digest that. Huh? Take your time, don't worry. It took me several years to digest that. I'm still digesting, so it's okay. It's like. All I'm trying to show you is the power of Mathematica, okay? There is no way you can do this in procedural programming with 2 commands. That's all I'm trying to say. I'm not saying procedural programming is not good. For certain situations, it's excellent. But most of the time, you take the power of, rules-based or functional programming, and it would be much simpler to solve many problems in Mathematica. That's all I'm trying to say. But I know it's not easy to think this way, especially for engineers. Yeah, because, the way engineers think is usually step by step. Yeah, so it takes a while to make that adjustment, alright? But usually mathematicians, physicists, they find it easier to make that adjustment. Engineers, they usually have a hard time. That's why they love MATLAB. MATLAB is always step by step. But once they start seeing a new paradigm, they realize that this is quite convenient actually, right? So, do you guys understand this? Yes. Yeah, this is scale. Kenapa Pak? Oh, ini. Kalau masih di dalam, bukan di luar ya. Kalau Bapak di sini, itu sudah di luar. Benar? Kalau Bapak masih di dalam ya. Alright, I want you now to solve the problem for three dimensions, alright? Using both pure functions and rules based. Can you guys do that? 3 dimensions, yes. So 3 coordinates, right? A, B, C. X, Y, Z, yeah? Using whatever list you want, alright? Just make up your own list and calculate the distance in a three-dimensional setting. X, Y, Z. Here we only have X, Y, right? I need you to do it for X, Y, Z. Guys, I discovered a problem with my exercise. So this is the problem. If I create a new list, right? New list, and I use 2, 5, let's say 2, 5, 3, and then 4, 5, 7, and then 2, 4, 4. Okay, so this is my new list, and I try to apply what I learned, right? And I say whenever you encounter something like this, yeah, correct? I want you to replace it with square root of a squared plus b squared plus c squared, right? Okay? So in principle, I would expect in Mathematica to give me, so 2 squared, 4 plus 25, 29, 29 plus 9, 38, right? Square root of 38, correct? But when I do this, Mathematica gives me something weird, right? Or this is correct? It's not correct, right? Okay, so we are confused. We don't understand what's going on, right? So let me introduce you to another function that is quite useful to troubleshoot. The name of the function is called trace. So you're going to trace step by step the calculations that Mathematica is doing. Alright? To implement that function, we use postfix notation here. Trace. So I want to trace all the steps that Mathematica takes to give me these numbers. Where these numbers are coming from? Huh? So, who can tell me what's going on now? Do you guys see the problem? Who can spot the problem? What is the problem? This is very common problem with patterns. The whole structure matches the pattern. You guys understand what I mean or not? No. Look at this. You see, we were expecting Mathematica to take the individual list, right? But Mathematica is taking the whole list. Why? Because the whole list has 3 elements. You guys understand? Look at this. If I change now, and I put, look, if I change this one, right? Let me change the initial list, the new list, and I change, and I put, another element. 2, 3, 2. or 3, alright? Now, if I apply this, my problem is gone, yes or no? So what was the problem? The pattern, exactly. The problem was I got a list with 3 elements, right? And inside those 3 elements, I got another 3 elements. But Mathematica matches the first level pattern, which was the entire list. That's why I got in trouble. Yes? But the moment now that I try to apply this, there is no problem. Why? Because the whole list is 4. So then it doesn't match the pattern, right? So now the challenge is, how do we fix our problem?
Make it 4.
Yeah, that's a good one, right. But imagine that we don't have the choice, we're coming up with a program, with a function, right? We're defining it, and then we don't have the choice about the inputs. So the input is 3, then we got a problem, right? I'll leave it to you guys to think about it. Think about how you would solve that problem. Alright? How can we tell Mathematica about that? Okay? So that will be kind of your exercise. If it's possible.
After lunch?
Yeah. At the end of today, we can discuss if there is a solution or not. Because I know it's not easy, but we can try to think about it. But anyway, so as long as we change the new list to 4 elements, the problem disappears. We can apply it. That was my intention, actually. Yeah. I didn't want to give you guys a hard time. That was my intention originally. Have you guys done it for the pure function? Have you guys created the pure function for the 3-dimensional distance or not? Sudah, belum? Have you guys done the exercise or not yet? Oh, you don't understand? Oh, okay, sorry. The idea then is, again, look, instead of using here two elements, right? Each list has 3 elements, correct? So I need to add one more element here. I need to add 1 element here, plus, right, my 3rd element. Alright? And then instead of using list, I have to use what? New? So, because each list contains 3 elements, right? So this is the square of the first element, plus the square of the second element, plus the square of the 3rd element, right? And I calculate the square root. Pardon me? Oh, my mistake, sorry. Thank you. So now, okay. So now the results will match, right? Okay, thanks. Yeah. Alright, so that's an example of pure functions and rule-based. We don't have time to cover everything, but I wanted to do it in the context of solving this one because, as I mentioned, the solution is being given to us in the form of a pure function, right? This one. Alright, so this was the solution. So f is a pure function, it's a cosine. Now the beauty of this is that now, alright, look at this. We can see how easy it is to replace, get the actual values, right? So if I use pure function, I just need to do one substitution here. Right? Because everything will be taken care of. But if I use the traditional approach, with this one, right, then I need to replace f and then I need to replace x. So it's a matter of efficiency, that's all. Alright, this is cosine 1 and this is cosine 1. But as you guys can see, the way this can be implemented is much faster, right? Because this directly takes the argument, right? Here I need to do two substitutions. First for f of x, right? And then for x. But don't worry, if you still don't master this, you can still do this. No problem, that's what we've been discussing. So, again, other example where we are getting rules, right? You see? Again, we are getting the rules, why? Because we are using not f of x and g of x, but we are using f and g. So, the beauty of this is, one more time, if you are trying to get the value, just directly, we replace by the solution, right? What is solution 1? Should be solution 1 or solution 2 here? Solution 1, right? Yeah, this is correct. Why? Because solution 1 is this one, right? The one inside. What if you want to find out the solution function f of x when x is 2.5? What about f of x? What will we do? The same, right? We will type f, correct? 2.5 and then replace with so 1 or so 2? Oh, we're still confused. Okay, it's right. If I type so 1, what should I get? I thought this is, right? This is the first element, correct? So again, I put so 1, because within so 1 I got both, right? F and G. Understood? If I want to get, okay, how would you extract, let me ask you something now. How would you extract only the function f from this solution? What would be the command? 1, right? If I want to extract g, it would be the command 1, 2. Yes? But I don't need to do that. I can directly put so 1, right? And then just use f, 2.5, right? Replace with so 1. And I got my answer. And I can do the same for protein. So this becomes much easier. Once you master it, okay? If you don't master it, don't feel bad. It's just a matter of efficiency. But sometimes you may not want to do that because it may be difficult to read the code. So especially at the beginning, this might not be the best idea, but you can see that it's very, very efficient. So we are using the same technique, right? We are replacing the f of x with the rules from the solution, and the g of x with the rules from the solution, and we are putting the solution from x equals to 0 to 3. Any questions? No? Yes? Yes?
Yes, thank you.
You're welcome. This is getting heavy now. So you guys are interested in learning more about math? We can use that? Yes? Alright, let's do this. Imagine that I ask you, give me the list of all the prime numbers that are between 1 and 1000. Sounds very difficult, right? Yes? Give me, yes?
Not say.
Because you're putting 2 and 5. You should be 2.5, right?
No.
Do you guys understand my question? Alright, so I'm gonna give you a hint about how you would solve it, alright? You have to use, of course, map. You have to use, what other function I gave you yesterday? For getting all the numbers from 1 to 1000?
Range.
Very good, range, alright? And you have to use another function that we haven't discussed yet, that is going to ask a number whether it's prime or not. Let me introduce you to that function, okay? That function is prime cube. Alright, so what I need from you is now to generate an output that will be something like this. True, true, false, false, from 1 to 1000. Ngerti maksud saya? Using a combination of map, prime Q, and range. And then crossing fingers. Together, alright? I can see that some of you are already experimenting, which is a good thing, meaning you start feeling comfortable with Mathematica and you want to, you know, do little things. So that's the idea. You learn something new, you try to apply it to something else, okay? So, what I mentioned to you earlier, I said, okay, if I got, let's say, range, right? So range 1000 will give me all the numbers from 1 to 1000, correct? So I can go step by step. Look, if I don't need to know to see the output anymore, I can just semicolon, alright? Now I know how it works. So imagine that I need to get the list of true false, right? So then I could use prime Q range 1000. Okay? Now, who can tell me why this works? Kenapa ini kira? Black, Untuk, hockey, or what? Listable, very good. Because the attribute of prime Q, one of the attributes is that it's a listable function. What it means is that automatically when I give prime Q and I use an argument list, right, then it will automatically apply that function to all of the individual elements, right? If I'm not sure, what I can do is attributes, right, prime Q, yeah, Untuk. Look, if the function is not listable, gapapa, we can get the same result doing what? We can get the same result doing map, right? Map what? Map prime Q, which is the function, right? Correct? To the range 1000. This is the way that we have discussed in class, right? Correct? So this is going to be my pure function. Yes, and this pure function is going to be applied to all the elements here. Yes or no? Look, as I said, in Mathematica there are many different ways of doing things. Whatever works for you. Actually, it's one of the things that I like about Mathematica, because you can really compute the way you think. Yeah, whatever really makes sense for you, once you start understanding all those possibilities, right? Now, in this case, the problem is, let's say, okay, I got the false, I got the true, but I don't know to what numbers that belongs, right? So, what I could do is, how about if I want Mathematica to tell me not only false, but to tell me 1, false, 2, true, 3, true. Bagaimana caranya sekarang? She already knows the answer. Ngerti maksud saya? Gimana kita bisa sekarang dapat satu list, right? A list with two elements. The first element the number, the second element whether it's true or false, the prime Q result. How can we do that? I just need to modify this, right? How? I put the number, right? You see what's happening now? So, when I apply this, Mathematica is going to give me first the number, right? And then, whether it's prime or not. But again, what I wanted actually was just a list of the numbers, right? So what I can do is use select. Right? Select the list. So it's the first 1000 numbers, right? And then the function, in this case, is prime Q. There you go. And I got the list of the numbers. Again, as I said, this is very difficult to do in procedural programming. And you see how easy it is to do it in functional. They're just applying functions. Prime Q. That's it.
Why one not prime number?
Oh, because it's not. It's a common factor all of them. If I ask prime Q1 is false.
Divide by itself.
Yeah, okay. That's an interesting point, right? Prime number. That's weird. Prime number definition. Positive integer greater than 1. There you go.
Oh.
I rely on the definition. So easy. But that's a good point. I mean, okay, what do we mean by prime, right? So just use natural language, get a definition. All right. Any questions? No? Okay, so let's move on to the next topic of how we can transform and simplify expressions. And sometimes Mathematica will give us the solution for an integral that is very complicated, but we know the solution is very simple. So by simplifying, we can get the one from the book, right? That happens very often. So how do we make those things happen? All right, so here is an example of an expression that, you may get when you are trying to do something symbolically, and it looks quite scary, right? Yeah, it looks quite complicated, but the first step could be probably to put everything together. So let's see what happens when we put things together. You see, now it's much easier, right? So from the very, very long and complicated, we got much easier to read, right? We can also try to simplify using trigonometric identities. Alright? And to do that, we can use either trig expand, trig factor, or trig reduce. Alright? Trig expand, trig factor, trig reduce. You guys can read about that in the help files, alright? So if we use trig expand, now it gets expanded, right? But if we put together again, we come up with the solution and we try to simplify, we also got a much simpler. So simplify for trigonometric expressions, we use trig factor, trig expand, or trig reduce. Alright? Now, sometimes simplify can work only with assumptions. So, for example, if I tell you what is the value of this, log of x of x, you guys would say x, right? But that would not work for negative or complex. We've got a problem, right? So we need to make an assumption, alright? Complex numbers actually. So we need to tell that we assume x to be belong to the domain of reals. So once we do that, then the simplification works beautifully. Here Mathematica doesn't do anything, but when I say this, Mathematica works as expected. Alright, so sometimes we need to make assumptions. By the way, the shortcut for this one is x escape lm escape reals. This is the sexy version, alright? So if you prefer this one, the shortcut is escape E-L-E-M, element, alright? If you want to know, you can always, use F1, element. Maybe this notation is a bit clear, or clearer than the other one. LM reals. In this case, we can also assume that x is greater than 0, and it gets simplified. So the assumption in this case has nothing to do with the domain of the function, but it has to do with the values of x. In this case will be, well, I'll tell you to put integers, right? Greater than 0. X greater than 0. Directly will do the trick. Or, again, as I said, could be 11 integers, right? And the shortcut. So in this case, for this one, we got two assumptions, that n belongs to integers and that x is greater than -1. So when we are trying to concatenate assumptions, more than one, right? We use two ampersands here. And, alright? If it's or, we will use two vertical lines. Or will be two vertical lines, alright? And will be two ampersands. So when we execute this, it works. And it gets really easy. Huh? Look this. But again, you would need to be familiar with it, right? Because if I try to do this without that, it's not simplified at all, right? So sometimes simplification in Mathematica is more an art than a science. You can try to use full simplify as well. Full simplify sometimes will give you results that simplify cannot. But it doesn't work always. In this case, it doesn't work. Right? So we need to put the assumptions, right? So what are the assumptions? N, Ln, right? Integers, and x greater than -1. Oh, sorry. X, my mistake. Greater than -1. Huh? Why is not working? Comma. Oh, my mistake, sorry. Yeah. Those are, yeah, correct. Thank you. Okay. But again, you need to understand the problem that you're facing. Otherwise, Mathematica, look, Mathematica is not something that will magically solve all your equations for you. You need to understand what you are doing. Remember, computers are stupid. Yes, so if we don't understand what we are doing, you ask Mathematica to simplify, well, there are no miracles, okay? But if you know more or less, you can guide Mathematica. That's the idea. Mathematica will not replace a human being, alright? Mathematica will make your job easier. Yes, but it will not replace you.
In the previous example,
Yes.
the assumption x greater than 0 is not necessary because x is squared, so it is always positive.
But complex numbers?
Oh, it applies.
Yeah, so Mathematica by default always will take the greatest domain, which is complex numbers. Alright, so under complex numbers, we will never have that happen. But that's a good point. That's why sometimes people get frustrated. Stupid Mathematica. How come I just to, simplify logarithm of a times b should be log a plus log b? But not always, like you.
Yes.
Because it's using complex. There used to be a package, especially for undergrads, where you only work with reals. So kids do not get confused. It's reals only. So let me actually see if we can find it here. Because you're right, sometimes it's very frustrating. You try to simplify things and you think, how come this is not working? Because complex numbers. So let me see if I can put the reals only. It doesn't, it's not here. If you Google it, you'll find it. Reals only package in Mathematica. Alright? And that will, why don't we do it? Let's do it now. Okay, so let me just go here, reals only. Package Mathematica. There you go. Okay, so that's where people get frustrated, right? So what they are recommending you is to use reals only or make assumptions. Okay. There, needs for older Mathematica versions, not Mathematica version 9, unfortunately, right? It's a version available in later versions and online. Oh, there you go. So we click here, we get it. Miscellaneous reals only. That was 2007. So you can download it and install it. So actually, before I forget, I want to give you the, I would say, 3 best resources for finding Mathematica stuff. 4 best resources, okay? So the first one will be this one. Demonstrations.wolfram.com. Okay? Here you will have directly interactive examples about your area of expertise. So, you know, you say black holes. How many people are interested in black holes in Mathematica? Well, you got 29 examples. But you can say whatever is your specialty, okay? So that's demonstrations.wolfram.com, and then you can just, you know, click on it. And if you have Mathematica installed in your computer, it will launch what is called the CDF player. Alright, so the example will become interactive real time. So you don't need to have Mathematica, you can have just the CD player and it will work. And you can change, you know, the arguments and it will work beautifully. Or you can download. If you have Mathematica, you can download the code here and you can modify the example to suit your needs. Yes, you can even see the code here. And you click on preview, you will be able to see the code. Alright, so this is the code that gets things started. So that's first, this is the first one. The second one that I wanted to show you is library.wolfram.com. So this used to be the primary destination, but it has been replaced by demonstrations. So more and more people are posting directly to demonstrations, they're not posting here. But what you can find here still are, you know, references to papers that use Mathematica, or references to books, or courseware. Yes, materials that you can use for your courses.
Learning center is also here.
Pardon me?
Learning center.
Learning center is a different resource, yes. Yeah. So I'll get to that one as well. So over here you can search for whatever topic you want. Forestry maybe. I don't know. Let's try. Oh, so for forestry there are no resources. What about tree growth? Yeah, there you go. So, you know, anyway, so here we got many different possibilities, alright? Come on. I don't know, it's other trading, let's try to find. Automatic day trading, company market simulation, empirical market. So, honestly, you know, this could be a very good starting point as well for your area of expertise, okay? If you need to learn more about Mathematica itself, yes, then we can go to www.wolfram.com/learning center. This is about you learning about Mathematica, not about your area of expertise, okay? But about the program itself. Yes, and from here you can choose your learning path. Okay, so you'll get redirected to the Wolfram Library Archive, the one we came from, right? You can be redirected to Mathematica books. You can also be redirected to Wolfram training. You can be redirected to Mathematica journals, videos. All right. This is a very good place. Yes. Now on the internet, there are right now 3 communities about Mathematica. Yes. The first community is called community.wolfram.com. And here you can join and you can try to find answers to your questions, or you can just search through the postings. People that use Mathematica on a daily basis, they post their questions here or their comments about different areas of expertise, okay? Even there is a special section for Raspberry Pi, because you can install Mathematica in Raspberry Pi now. So you can, attach it to GPS or, do a lot of things. If I click here, for example, under search, Raspberry Pi, or maybe I'm misspelling. Raspberry. Yeah, there you go. Alright? So this is the first one, community.wolfram.com. The second one is Mathematica, Stack Overflow.com. What is that? Sorry. It should be Stack Overflow, right? Yeah, how come it's not letting me? Okay, never mind. So, this is stackoverflow.com. For example, this is an example of how you find Waldo using image processing in Mathematica. For those of you who might be interested. For image processing, and it tells you step by step how to find Waldo, and Mathematica will give you exactly this. So, that was weird. Mathematica stackoverflow.com should be one of them, right? And the third community will be groups, groups.google.com, and then you will search for the Mathematica group. Mathematica. And one of the groups should be the Mathematica group, alright? Yeah, Tom sees of Mathematica. So this is the group, and here you got, learning to program in Mathematica, for example. There you go. So maybe you guys may be interested in this. And here are some of the answers. Math programming, this is a book for free. General programming, the Mathematica cookbook. Alright, this is a more complete reference. So, I think those resources should be more than enough to get you started. Of course, you can always contact me. Library.wolfram.com, alright, demonstrations.wolfram.com, and then community, Stack Overflow, and the Learning Center. Yes. And of course, my advice would be to start with the Learning Center first. Once you get the solid foundations of Mathematica, then apply them to your area of expertise. But if you try to directly get to articles about how to use Mathematica to your area of expertise, you may be a bit lost. Because they use the code and you may not be familiar yet. But once you get the basics right, it should be very easy to catch up. This is very good. This is excellent, but very difficult to follow. Alright? This is okay. This is kind of the easiest one to follow. Alright? This is advanced. Michael Trott is very good because it contains thousands of examples and the solutions as well. So they are available. But people usually start with the Mathematica book, they move to this one, and then they move to Michael Trott, David Warner, and Shifrin. This guy has published the book for free. Alright, there you go. So this is what I was trying. Mathematica, stackexchange.com, yes. So this is the Stack Exchange location for Mathematica. And you can ask any questions you want. Usually they will reply to you within 24 hours. All the Mathematica gurus, go here. For real, believe me. Right now, this is the most advanced place to post questions about Mathematica. The Mathematica Stack Overflow. You might be a little bit overwhelmed right now with all the information I'm giving you, but remember, you just need to know that there is something there on the internet that might help you. That's all. You don't need to remember everything. Who wants to remember everything? Remember that there is a place that you may find a solution. Look, learning finance with Mathematica, Mathematica for computer scientists, what is the best Mathematica tutorial for young people. So, you know, whatever suits you, leave it here. Or you can always ask me. I have access also to plenty of resources. Or I have built resources myself, so I can share with you. Don't have any problems. If you need resources for ODEs or PDEs, I can give you, or optimization. I create it myself. So that'll be fine. I'm happy to share. Alright? So, yeah, before I forget, I wanted to share all those things with you. You know, this is the idea for transformation with complex numbers. So instead of trigonometric, right, this is complex numbers, you can use complex expand, exponential to trigonometric, or trigonometric to exponential. And you know, what you guys could do now is you could try to start solving the exercise, first 3 exercises, alright? Before we take the lunch break. How about that? You practice a little bit. And then in the afternoon we'll cover the 4th tutorial. And then next time we'll cover the last 4. Yes? Oh, cool. You have the phones. You have the phones. You can use it.
Great. Thank you.
You want? Guys, feel free to have lunch now. When we come back, we can continue having fun. Okay. Welcome back. Thank you for not quitting on me. So, remember I gave you exercise, right? And I said, think about this problem. Remember, we got a situation where the whole list might match the pattern, and we did not get what we were looking after. Ingat? Belum? Sudah lupa? Ini, dulu kita ada new list, benar, untuk 3 dimensi. Untuk hitung distance. Ingat? Yeah. Tapi kalau kita pakai pattern seperti ini, gagal, right? It fails, correct? And the reason for that is because the whole list had 3 elements, right? So the whole list matches the pattern. Bagaimana kita bisa perbaiki? How can we fix that, right? This is the key, alright? We need to tell the pattern that the head of the expression should be an integer. Belum ngerti ya? Tidak apa-apa. Alright. Let me show you something. Alright. So if I put this function, alright, and I say this function equals to x cubed, it means everything will be cubed, right? So I put f Ruben, hasilnya Ruben cube, right? F3, correct? So it's f of anything. But I can limit that. Let's say I only want it for integers. So what I could do now is I could put g, x, integer. Alright? Then this would be x squared. So only for those arguments that have the head integer, alright, Mathematica will give me the square. Anything else will not give me anything. Gerti? Okay, so I'm limiting what I want, right? So if I execute this and now I say G Ruben, ya gana. Karena Ruben bukan integer ya. Kalau check Ruben, head symbol. Tapi kalau saya G2, hasilnya apa? 4. Kenapa? Head 2 apa? Integer. Ngerti maksud saya? Gara-gara itu kita bisa sekarang dapat hasilnya yang benar kalau kita restrict the heading to integer. Yes? Because this is a list, right? The first 3 elements are lists, bukan integers. So if we change this, we add the integer, then jalan. Understood? Can you guys create a function now that will only give me the square root of a symbol? Create a function now that will only give me the square root of a symbol. If it's something else, it will not do anything. Alright? Can you guys do that, right? Very quick, in a couple of minutes. Create a function that will only give you the square root of a symbol. In 15 minutes we start the new topic. If you have any questions, please raise your hand or shout, whatever you want. Yeah. Let's try to understand what's going on here, right? Why this works. So if you want to understand what's going on and you would like to know why this works, we can try to take traits here, alright? So then we see that, Mathematica is just checking that the head of the elements of the list are integers. And because of that, Mathematica gives you the correct solution, right? But if instead of doing this, I use, new list, and I replace that with A, B, C, A squared plus B squared plus C squared, what you're going to see is that underscore trace, you're going to see is now is different. You see? Here is for each element, right? But here is the entire thing because the entire thing matches the pattern. Alright? That's why it doesn't work. So that's why I said trace can be very useful in trying to understand what's going on, because sometimes we are confused. Okay, this is a very common issue when you are trying to use patterns. That the whole thing matches the patterns and then nothing happens. Yes? So to avoid that problem, we can use either integer or we could use something like this. We could use this kind of pattern. Instead of putting integer here, we could try to put something like numeric cube. So we are checking that the pattern is a number, alright? Yeah, so we got many different ways to limit the patterns. So we can just make sure they are numbers. Yes? So if you are dealing with integers, you can just limit to integers. But let's say you are programming, and then the result could be, reals, could be integers, could be complexes. So basically, in this case, you just change the way you define the pattern, and you ask the question whether the number is numeric, the input. So both cases will work, but this will work also if you change this to reals, right? Because reals will also be numeric. Again, I don't want to give you too much information because they overwhelm you, but that's how you can restrict patterns. And that's something that is being discussed in topic 7 and 8. We don't have time today. The next time we run the training, we'll cover the last 4 topics, and that will include this. But anyway, in the meantime, you guys now have some ideas. All right. So let's continue with the fourth topic now. The graphics. Do you guys have any questions about the exercises? You have any questions? You can ask me. Otherwise, let's do some graphics. Right, so how can we make plots of functions? Of course, how we make plots of data? How do we deal with axis labels? And how do we work with graphical elements? So after this, you guys should feel pretty comfortable with commands like plot, that you are already familiar with, plot 3D for three-dimensional graphs. But the structure, as usual, you guys already know, right? So plot, the function, and then the range, like in this case.
Last time we changed to the degree.
Yeah, correct. So if we want to change to degrees now, we could put sine x and then degree. Alright? And then instead of 0 to 6 pi, it will be, what, 360? 360 times 6, right? If you want to use degrees, anyway, if you want to use radians by default, right? But if you want to use degrees, then you need to put, after the x, you need to put degree. But of course, the range also has to change to degrees, right? So it will be 360 degrees times 6, because it's 6 pi. And sometimes, you know, people get confused with that because they put sine 90 and then they don't get the result they're expecting. So you need to put sine 90 degree. Like this. A typical example, someone who first started with Mathematica, why would I know sine 90? Mathematica doesn't understand. Alright, so okay. Alright, so that's how we can put it in degrees. And then we can also choose the range. Alright? So plot range. And in this case, the range will be limited only to 0 to 1. So you see, you can control the y, right? The y-axis. What do you want to display? Remember, one option that we saw yesterday was plot range all. Yes, because sometimes the graph gets cut, right? You want to display everything, you put plot range all. But if you want to fix just part of the range, then you can put plot range, then from 2, right? Can you guys show me the range of this from 0 to -1? This is from 0 to 1, right? Can you guys create it from 0 to -1?
-1 by 1.
The plot range will be what? How do I fix that?
-1 0 to
-1 0. Can I put 0 to -1? Let's try. Maybe we cross Mathematica. Who knows? Mathematica understands both ways. So whatever makes sense to you, right? Plot range. So then we can use plot 3D. So in this case, plot 3D has the same structure, but we have two variables, right? So we got x and y, and of course z as the result. But look, now we got more options, right? We got axis label, we got mesh, and we got viewpoint. There you go. And now we can modify anything you want. And so feel free to, you know, play around with mesh. If you want to put mesh through, you can see the differences, alright? If you want to know all the different options that you have for plot 3D, remember the command, right? Options, plot 3D. And look at this. You got a lot of options, right? All those things that you can control. You want to see how many options? Just put again length. 74 options that you can use to modify making three-dimensional plots. So that should give you a pretty good idea of all the things that you can do, right? You can make very, very nice graphs. But of course, you need to spend time mastering all those options.
Is that mesh?
Yes.
Mesh for
Pardon me?
mesh.
Mesh are the mesh where it's used to create to calculate the points. So this is the mesh. That's okay, we can take a look here, we can read the definition. So it will tell us it will tell you the basically the surface, right? So how many horizontal lines, how many vertical lines, right? At each intersection you calculate. So by default, the mesh is all. If I'm not mistaken, we can take a look at the default here. Right? Mesh, control, epilog, F. Mesh, automatic. Okay. So Mathematica will choose the best number of horizontal, for x and y. And from those points, come out with the value for the function. You can modify that using mesh functions, mesh shading, etc. etc. Any other questions? No? Alright, so here is my challenge for you to keep you busy for the next 10 minutes. I need to plot a circle. Circle, alright? Radius 1. And the center of the circle is 0, 0. You guys know the equation of the circle? Yes, right? X squared plus y squared equals to 1, right? Okay, I need to plot it in Mathematica. Bagaimana caranya? The answer is no plot, and the answer is not plot 3D. Plot 4D? 2D. No. The answer starts with C. C, plot. How can you make a beautiful circle? Huh? Using contour plot. Right? Just go to the help and check for something similar what you are trying to do. That's what I'm trying to teach you here. That's very useful skill, believe me. It's impossible to remember all the stupid commands in Mathematica. Nobody wants to do that. We don't have time, your head will explode. Yes or no? But it's very important that we know how to read the help, right? So if I know that I can use contour plot, then the first thing I'm going to do is I'm going to just ask, okay, contour plot. Okay, so I ask, right? And I got information. Well, maybe it's not what I'm looking because I'm missing the examples. So never mind, then I highlight it, I put F1, and I look for it, right? Ah, look, this is what I want. You guys understand? I don't need to know the answer. I don't need to memorize anything. I just need to go to help and read carefully, that's all. Most likely the answer will be here. Of course, there may be times where the answer is not there, but then we can look for other sources of information, right? A lot of times the answer is here, so now that I know the template, then what do? I apply it. So contour plot, what's that? X squared plus y squared equals to 1 for x minus 1 to 1. I mean, you can choose whatever you want here, alright? If you want to get rid of the frame, you can do it from here, alright, off. Or if you want, you can just enter a new command, a new option here, frame, false. Alright, so don't worry if you don't remember how to implement the formula. Check the help, right? It's great, honestly. I don't remember many functions. I forgot how to actually set it up, but I constantly use the help file. It's really useful. So that's what I'm trying to encourage you to do. Alright? So let's try to, you guys can experiment with the other ones, density plot, parametric plot 3D. The structure will be similar. Yeah, so depending on the kind of problem you are facing, you could use those different ones. All right. But let's try to talk about how we can plot data. Let's take a look. So the first thing that we can do is we can generate data. All right, and then we can just click on list plot and join true. So what happens? What happens if I remove the join true? What happens is I will have only the points. Understood? So the other thing that I can do is list. There is one join list plot. There is one also option. Let me show you. That will list line plot. All right. So we don't need to use list plot. We can also use list line plot, and it will create the same graph. You see? So as I said, there are many different ways of doing things in Mathematica. You can use list plot and then join true, or you can use directly the list line plot. List line plot will directly do the lines for you. Alright, some other examples: list contour plot, list density plot. So here is another example. We use a table to generate the data, and then we create the list contour plot. Okay, so let's try this. Create a list, all right, using table that will contain. Oh, we haven't discussed table yet, right, in class? We have, all right. So create a list that will contain two random numbers between 1 and 10. Yes, and then plot those data points. So there will be 10 data points, right? Each one 2 dimensions, x and y, and those 2 dimensions will come from a random number between 1 and 10. Yes? The only function that we have not discussed yet is how to create a random number between 1 and 10. I can give you a hint: random integer. Yes? Random integer. So, all right. So this is the idea, right? So look, I could, if I'm already comfortable with Mathematica, I could do just this, right? So list plot, transpose of random integer, then random integer, and it didn't work. Why not? Okay, so let's see why it didn't work. Oh, I forgot to put that I need 10 random integers, right? 10 and 10. And that was my mistake, sorry. Alright, so now I got those 10 numbers, right? And I'm linking them together. But if this looks too complicated, alright? If this looks too complicated, alright? So this is the shortcut for function. So instead of closing 2 square brackets, I can just put ampersand here. So I'm just lazy. But again, if this looks too complicated, it's okay, we can do it step by step, right? So let me put here again X coords, right? And I'm gonna put random integer, right? And I'm gonna put 10, 10. 10, the first 10 means a random number between 0 and 10. The second 10 means 10 times. So I get 10 random numbers between 0 and 10. Alright? Now, if I don't need to see the output, I can just close it, right? I coords, I can do the same, random integer, again 10, 10, right? And then I can link both of them. So I can do transpose, and then remember it's going to be a list of lists. So I need to put transpose, then curly brackets, right? X coords, comma, Y coords, right? And then I can just name it data. Yes? And now what I can do is list plot. But again, if you already feel comfortable with Mathematica, you can do something like this directly. Yeah? It doesn't matter which way, you will get the same result. This is the fastest way to create a function, alright? When you just put the ampersand there. Sorry, the ampersand, the at sign. At. You just plot at those results. Any problems? Any questions? No? Yeah. Somewhere else? Oh yeah, of course you should extend it. Gimana? Sudah? Alright? So let's talk in more details about other additional plots. You can have log plot. When you need the y scale to be logarithmic scale, you can have log plot. You can also have bar charts. So here's an example of log plot. So the vertical scale could be logarithmic. And you can have also bar chart. So in this case, Mathematica will create a kind of chart. You can change the chart style if you want over here. For example, you could use arrow rectangle, and you could use glass rectangle. So feel free to play with it.
Circular.
Pardon me? We could look at some of the things that they are here. I'm not sure we could have the circular, but that's a good point. Let me check, alright? So I can go to chart element function here, and I can look at what options I have.
Yes.
So chart element function, and let's see. What options do we have? Oh, interesting. So I could try to build my own, but I'm not sure I could get the circular by default. But let me check again. More. No, I think chart style. Yeah, I think that would be the ones that Mathematica is given me. So, yeah, I'm not sure we could get the circular one. Maybe we could build it ourselves for the chart element function. That's a good point. I'll do some investigation. Because here, okay, let's see, class circle. If I change this to circular, right? No, Mathematica doesn't understand that. But it was worth a try, right? So it looks to me that it's not, by default, it's not there included. So these are the only ones available. By default, but you could create one. Alright, so now we can talk about axes and labels. And so we could use the here. So this is the nice one, right? So take a look at this because you guys may want to create professional looking graphs, and then you will have to give all those options. So you guys can use plot label, right? Cosine x and sine of x. You can use the frame as true, frame label, right? You can label the frame. You can also use the plot style for dashing. Dashing for the first function, which is sine of x, right? But you can see that dashing here is empty for the second function. So it's being left that way. You can also see the frame ticks. So we don't need here frame ticks are 0, 0, right? And pi, pi, 2 pi, 3 pi, 3 pi, all right? And then they are automatic. None and none. So as you see, so these are the 0. These are the ticks, right? 2 pi, 3 pi, and then automatic.
I think the question is polar plot.
Oh, the question is polar plot. Sorry. The question is polar plots. No problem. Then we can ask Mathematica. There you go. Was this the question?
Itu bukan? Bukan. Yang kayak kue. Oh, pie chart.
Oh, pie chart,
Pie chart.
If it's, yeah, okay, so then pie chart. Yeah.
Oh, yeah.
But it's a different type of graph, right? We can have a pie chart, yes, of course. But that's different to changing the shape of the bar chart. Yeah, we can have polar plots, yes, you're right. We can have pie charts, yes. So there are many different kinds of charts and plots that you can do in Mathematica. Yes. Actually, the strength of Mathematica is kind of the visualization, all right? The quality of the graphs is truly amazing. So this is just one example. So what I would like you guys to do now is modify this example. So the y ticks, all right, the y ticks are only 4 points, -1, 0, and 1. Gerti masuk saya? Ini x ticks 0, pi, 2 pi, 3 pi ya. Y ticks banyak, terlalu banyak. Ya. Can you guys modify this example so the y ticks are only 4, -1, 0, and 1? Yeah, seperti here. I have 0, pi, 2 pi, and 3 pi, right? But here I have a lot. Yes? I just go from -1 for -1, for 0, and for 1. Now you guys modify this example to get that. The easiest way is duplicate the previous input, right? Remember, Control L. Control L. It will duplicate the previous input. And you guys already know which one you have to modify, right? Yeah, the automatic ones. Very good. And what do we need to put here? -1, 0? Okay, so if that's the case, like this. Like this. Alright? Alright? Very good. So we can practice. So you see the ticks are being labeled using which way? The clockwise is starting from the x, right? X, y, Right. That's how the ticks are being put. You could put the ticks also here, on the upper side of the frame, or on the right side of the frame. Do that. Already, okay? Good. So this is the float style, frame ticks, automatic. We can check the options, alright? So now we can talk about the graphical elements. And we can again create graphical objects using a combination of what we call graphics primitives. Graphic primitives can be something like, line, point, circle. So if you want to create a line from point 11 to point 22, this will be the command. Yes? But to display that, we will need to say that that's a graphic. Let's take a look. So this is the idea, right? You see, I create the line, so this line is going to go from 1, 3 to 2, 2, then to 3, 5, then to 4, 4, then to 5, 7, right? And I need to tell Mathematica that I want to display that, so I use the command graphics. And then I say that the image size should be small. There you go. So, what I would like you guys to do now is create a square from point 0, 0, right, to point 0, 1, to point 1, 1, to point 1, 0, to point 0, 0. Get it? Using line. Yeah? Name it my beautiful square. And make it red. Sorry, it's a square or rectangle. Yeah. Good. So, the idea, right, was for us to replicate the structure here. Control L, right? And then the line, as I said, it was going to be from 0, 0, right? To 0, 1, to 1, 1, to 1, 0, right? And then do 0, 0. Correct? Okay, so once I do that, I got my box. But my box is black. Saya minta warna merah, benar? Okay, so I put the command here red, and that's it. Or I can put, darker red 0.6. That's another way of putting the color, just different color. Yeah, what happens if we put where? The red? Then he might not understand. Or he might understand. Let's take a look. That's a good point. Let's see, if I change this darker here, right? But I need to put it inside the curly brackets, right? It doesn't understand. So it needs to create it red first. If you take a look at the example, because otherwise what is going to happen is it's going to be overwritten.
After curly bracket also.
Okay, if I put it out the curly brackets, let's try. Alright. I put red here. It doesn't understand. It gives me an error message. An improperly formatted option was encountered while reading graphics. Why? Because if I put it outside, right, this option belongs to what? Belongs to graphics. But you see, red is not part of graphics. You see, there is no option here that tells me red, so Mathematica is confused. So what I can do is I can check line, right? And I can see how it's being done. You see, and I got examples here. So it's telling me how it's been implemented, right? So I can just little by little I can try to see an example that will match my needs. Dash, graphics, ping, you see, or dash, but it has to be inside curly brackets, right? And it has to be the first one. Any other questions? No? So if I put here thick and red, then it works. Yeah, but if I put it somewhere else, it will not work. So that would be some options. I can also use polygons, alright? So this is just a great example about all the things that you can do. Okay, so why don't you guys work on the exercises now? For the graphics. If you get stuck or you need some assistance, just let me know. If you are finished, let me know, I'll give you more. So you don't get bored. If you are finished, yes? If you are finished, try this. Sekarang ada ujian, final project, right? All right, so let me tell you your assignment, all right? Let me put text here. Create a plot that will show the evolution of the price of the bank BCA stock in IDX from January 1st, 2008. Good luck. Okay, sorry. Let me give you something else. Hints. So I need to make this text. Style text. I'll say it. So, hints, alright? Hints. Please check Mathematica help for financial data. But only if you are finished, yes? Only if you are finished. Huh? This is difficult. So only if you are finished, try to figure it out. If you are not finished, keep on working, don't worry. Pardon? 1, 3, 4, oh, yeah. Yeah, correct. Try to figure out that one, yeah. 4. Alright guys, I apologize for question 4.4. Please ignore question 4.4. Please ignore the log scale. Alright? Ignore this part. Alright? Don't worry. You guys feel free to skip the last part for the log scale. That has been already superseded in Mathematica 9. So you don't need to worry about that. And if you check financial data, you know, we go to financial data here, and under details, we can look at all the properties, all right? So the property that we are looking for is...
Please make the one run harder.
Oh, sorry. The property that we are looking for is exchange. Sorry. So we are looking for this property, right? Exchange in which financial entity refers. So the problem with Mathematica functions is sometimes, they are so complete that it takes time to go through the examples, right? But, we can look at some of the examples here and try to figure out. So, you can go to the scope, specifying exchanges. You guys know what I mean? So here we go. So this could help us. Otherwise, looking up names, right? Or classes, there you go. This is it. This is the one that we want, alright? We want financial data exchanges. So now, if I go financial data exchanges, I know, I don't have internet connection then. It looks like my internet connection is dead, so I cannot do it. But anyway, so when you do financial data exchanges, you will see the list of all the exchanges, and then you will see one of them is Jakarta, right? So once you know that, then you have an idea about how to get to the next step. Yeah, so maybe the internet is down. Yes? All right.
I don't know.
Oh, okay. So then don't worry about it. Then if Mathematica is weird, sorry, maybe it's my mistake. Then I can just quit the camera. Don't worry. I'll quit the camera and I'll try it. Maybe it's a problem with Mathematica, yeah, because it's telling you it's working fine, then. So the kernel went crazy. Kadang-kadang, ya, Mathematica seperti mabok, ya. But if that's the case, we quit the kernel, we restart again, Mathematica is back. So as I was mentioning, you guys see that we got the name for Jakarta. Yes, Jakarta. So we don't have IDX, we got Jakarta. Right? So that's already giving us some hints. Yes? So if we already know that, then I can do what? What is what I can do? I can do as follows, right? I can do financial data, and then I can put Jakarta, right? And then I can put members. So all these are the members of Jakarta Stock Exchange, right? Ado Pusi. Yeah? But that's what I said, this is the final exam, this is a project, because this is very difficult. If you don't know the answer, right? You're trying to look for the answer. Now, what I need to know is as follows. I need to know BCA, right? So what I need to know is, what is the company, what name is this symbol, right? You guys understand? So, to do that, I could use map. Dito masuk saya. I could ask, right, to get the name, I will apply a function, right, that will give me the name for each and every one of these symbols. You guys understand? Yes or no? You don't understand yet? Okay. No worries. Let's go to help. Sorry, let me just go financial data help here. Yes, so you see, I'm gonna have GE, for example. Sorry, let me make this bigger. Because this is part of the learning process in Mathematica, right? So you can see that I got GE, and I can ask market cap, right? But what I want to ask, actually, is I want to ask for the name, right? Yes or no? So I'm gonna look for the property name here to see I got, look at that. You see? English name for a financial entity. You guys see? I got that property, right? Okay, so knowing that property, I go back here, right? And let me try now this. Financial data, alright? And the name, let's say JKAALI, and I'm gonna ask for name. Okay? Understood? see, I'm just trying to follow the hellfire, right? The step by step. But of course, what I need to do is I need to apply this function to all the stocks in the Jakarta Stock Exchange. You guys already know how to do that because I have taught you how to use pure functions and mapping, right? Yes? Alright, good luck. Yeah? You wanna take a coffee break first? Huh?
Yes.
Before you submerge yourself into... That'll be fun. Huh? But don't worry, that's what I said, this is difficult, alright? Otherwise I wouldn't say it was the final exercise. I want to finish, this event. Hopefully we'll see each other again later on this year, July, August, to cover the 4 next, tutorial materials. With one example of the power of Mathematica, right? So what I'm going to do now is I'm going to show you how easy it is to create an interactive application to check the evolution of the stock of 3 banks. For example, BCA, BRI, and BNI. Yes, I know you guys already know how to do the date list plot, right? Dalia la Bonchor, so the news spread. Yeah, Papa, no problem. That's good. So, because you guys already know that, you know that I have to use what? Date, list, plot, right? And I have to use what? Financial, data, Rus, JK, BBCA, yeah? Correct? And then 2008. Oh, gak usah. Saya bisa langsung dari sejak 2008. Okay, so if I do this, correct? I got it, right? Yes, okay. But now, imagine that what I want to do is, I want to make this interactive with 3 banks. Alright? So, what I'm gonna do is, I'm gonna wrap everything with the command manipulate. I have not discussed the command yet, because it's quite advanced. But you guys will understand how easy it can be to, create interactive examples in Mathematica. So manipulate, and I'm going to change this JK BBCA with just bank. Alright, so this will be my parameter. Alright, bank. And now, what I can do is, this bank will take the following 3 values. JK BBCA, alright, JK BBRI, and then JK BNI. And I close the list twice, and I close manipulate. Yes, so now when I press Shift Enter, you see what happens? I got, try to do this in MATLAB. Good luck. I mean, this is just a very basic example for finance, but you can think of thousands of applications. For physics, for forestry, for whatever. Even, let me show you another example. You can just use here manipulate for plotting trigonometric function. Okay, that's the last exercise for today. Why don't you guys create a manipulate that will plot 3 trigonometric functions, either sine, cosine, or tangent. Can you guys do that?
Wait, we must put apostrophe in the...
Oh, because that's how Mathematica will take data.
Oh.
So that's the format that Mathematica requires. But for other manipulates, they may require, symbol, or it may require something else. Sorry guys, I apologize. Earlier, I forgot to mention that for manipulate, alright, manipulate, alright, alright, sorry, let me put here expand, alright. What I'm trying to say is that when we create the manipulate, we don't really need to put strings. So it depends on the type of activity that we are trying to do, right? So if I'm trying to expand this, I can put from 1 to 10, an increase of 1, alright? So you see, now my n is just numbers. You guys understand? So if I do this, right, and I want, wow, a lot of Ruben's and ITBs all together. And we can actually make a movie. I know it's a silly example, but I'm just trying to show you the power of Mathematica. That's it. So it's going, n is going from 1 to 10, right? And it's expanding that. Alright? Pretty cool. And what I'm trying to say is that n, in this case, is just an integer. So it depends, right? So for the trigonometric function, sorry, let me stop this. So for the trigonometric function, we just need to put manipulate, right? Manipulate fun, and then x between whatever we want, minus pi to pi. But then we remember that when we want this, sorry, I forgot plot. Plot, fun, right? And I close plot here, and then what I can say is, fun will be what? Will be either sine of x, right? Cosine of x, or, but in this case I need to give the actual functions. Alright? So that's the idea. But you can imagine the power of this thing, right? And all the things that you can do. Oh yeah, sorry. Kidding. Yes. Oh, so before I forget, one last thing, in case you guys are interested in buying, let's say, one book about Mathematica, right? Of course, you could buy the book for your topic, but if you want to really get an idea about the power of Mathematica overall, and you only have budget for just one book, yes, this is the book that I would suggest you to buy, right? So let me go to Amazon.com really quick. And yes, the book I would recommend you to buy is this one, Mathematica Navigator, the 3rd edition. This is a great book for, getting an overview of the power of Mathematica. Mathematica Navigator, 3rd edition, by Ruskipa. He's a Finnish guy. So this is the one that I would really recommend you to buy. Because it covers honestly everything. It covers, optimization, differential equations, calculus. It covers graphics, programming, image processing, everything. Hopefully there will be a new edition coming that will cover Mathematica 8, 9, and 10. But right now it stops on Mathematica 7, but still it's pretty good because it also teaches you about computable data, chemistry, physics, etc., etc. Finance. So it's a pretty cool book, this one. So if you have to buy just one, this is the one I would recommend. Mathematica Navigator, alright? For programming, as I mentioned, I give you some examples. The latest one is this one, which is pretty good. Programming with Mathematica, but Paul Welling. Paul Welling actually used to work in Wolfram as the head of training, but he left a couple of years ago. Couple of years ago, yes. Yeah. But anyway, his book is very easy to follow and will really give you a strong, foundations for programming. It's quite thick. It has over 700 pages, but the good thing is all the exercises come with solutions. Alright? Mathematica Navigator also has hundreds of exercises, and it comes with the electronic version, so you can install it in your computer. Alright? So that's all for me. If you need to contact me, please, because I think I have run out of business cards, I'm really sorry. Send me an email to, let me just change the size of this format, size. Send me an email to ruben@naventaindonesia.com. And I'll be more than happy to help you. And if I cannot help you, I'll get someone to help you. So ruben@naventa-indonesia.com. If you come to Jakarta, visit our office. We have about 100 books about Mathematica. I've been collecting them since '97. We are in Sudirman, so we just recently moved from Grahamandiri. So we moved from Grahamandiri to Artaloka, which is in front of Busway.
Oh.
So it's transportation-wise, it's quite easy to reach our office.
But your address still...
My email, my phone, everything is the same. Yeah, it has not changed. It's just recently the office moved to Artaloka from Grahamandiri. Yeah. The 10th floor. Yes.
Bebas banjir.
Yeah, bebas banjir. So it's been a pleasure. Please continue playing with Mathematica. Yeah. Remember, use it or lose it. But the most important thing is remember the 3 golden rules. That's it. If you're consistent with these 3 rules, you will make progress very fast. But you have to be consistent. Otherwise, Mathematica will not work for you. Of course, if any time you need some help or advice, just send me an email. And I'll see you guys in a couple of months. You have time to practice now. That's it. So thank you. Yes.
What's the person It is the same book?
Oh, no, this is mathematics, not Mathematica.
Oh.